Hello and welcome to this video about ESP32 with ABMT. I've created a runtime, so now you can execute the models that you want on an ESP32. What we see here is a display and an ESP32C3 running the display demo. Here I have some ESPs that I've tested. I talk about that a bit later. So let's look into the model we are running. We are running the display demo in the ESP workspace, and the model is ESP32. So this is the demo. We have an input here, a state machine, JSON display node. We rotate this. This is not in the demo. I added this a few seconds ago. And here's the display from the UC devices. You can look into that. And I make another video about the display demo and the JSON stuff. I just wanted to show that this is possible. When I press the button here, it changes the icons. Just a sneak preview for the display demo update. I already made the display demo example. I just want to show what's possible. So this is the ESP running, and let's quit this here and we go to explain how you can do stuff like that. So the ABMT community GitHub page has a lot of repos, and we are talking mainly about the ESP nodes and the runtime for ESP. Here's the display demo and the devices. I make a video about that. We focus on the runtime for ESP32 in this video. So how do I get started with this stuff? Create an empty workspace, add this repo here, add the ESP nodes repo, and then you're ready to go. Here's some installation notes for the dependency you need for the ESP IDF. We are at version 5.2.1 for this video take. They're updated every time, and sometimes it's more stable. I've had a lot of trouble. It's too big. It's a bit annoying, but at this point it's pretty stable. So let's move on. So okay, we start here with ABMT and the ESP nodes HTTP example, HTTP LED, and I take another ESP for that. So let's take this one here. This is a C3 board. I use this in most of my projects because they're very small and very low power. And cheap, of course. It's a RISC-V, a single core for most applications. This is more than enough. Power consumption is very good. Here I have some C6 boards. This has very bad connectivity and a small pin header. I'm very happy that React Studio came out with this one. Maybe sometime I will switch to C6 as main processor, but for the current projects I use the C3 for most of the times. The classic ESP32 here works also. We talk about SDK configs a bit later. So let's start with this. We plug in this one here. So let's see. So that's good for now. And we start the HTTP LED demo here. So let's get this up running. And while it's flashing, we move to our GitHub page. So installation, basically dependencies, get the IDF. Remember the path where you put the IDF, because when you select the runtime here, ESP32, then you have to add the path here. Yeah, so that's that. Then you need to install the dependency from the IDF. You need to add yourself to the dial out group. This is all depending on your distribution you are using. So yeah, you may need a logout, you may need to restart, yeah, depending. Maybe it's all already configured, so you have nothing to do here. Yeah, add the ESP nodes to your repo, add all the dependency. Maybe you want to use UC devices for display drivers or some peripheral drivers. Yeah, and then if you want to use Wi-Fi, go to your RT ESP32 directory and edit the Wi-Fi config. Let's go into here. Here you can add your password and your SSID. Yeah, then it's global for all of your projects that are running this runtime. For special use cases, you can add a function call instead of the strings, but yeah, that's a bit too deep for this introduction now. So when you've configured your Wi-Fi dependencies, you're ready to go. And we starting with the ESP nodes HTTP example, HTTP LED. Yeah, just to get started here and see what we can do. So, oh, it failed compiling. What's wrong? Port doesn't exist. Yeah, stupid me. This is not plugged in correctly. Now it's plugged in. Let's see if it goes. We have a C3. That's good. Wi-Fi mode. Yeah, power saving and low power we talk about later, but I make another video, I think. So now it's linking. Let's see if it works. Yeah, I go back here to the RT ESP32 repo because we want to talk about the stuff here. Okay, so yeah, we are connected here to our to our ESP node, and it's trying to connect to my Wi-Fi. So now it's connected, and yeah, let's talk about the model first before we start with this. So this is the model. We have a TCP server here. We have an ESP HTTP server running on this server. So here we have running on port 80, and we have a simple REST node for the REST data. So what we can do here, we can change our LED value with via a REST protocol, and here is the data pipeline for parse this JSON file, get a value, so we get the key value, the default value is 100%, and then we make some pre-processing and then setting the PWM output here. Yeah, and here we're sending something back. Just like the REST example in the examples directory. So nothing special here. The special thing is this HTTP server. This HTTP server gets the HTTP files and compresses them and flashes them on the ESP. So yeah, let's talk about this right now. So we are in the ESP nodes, and this is the project directory we're in. So yeah, you see that here that we are in this project. And when we have an HTML directory here, all the files are flashed on the ESP and are available via this ESP runtime. This is project global. So if you want to have another files, make another project. So yeah, that's the difference between project and configuration. I've talked about this a lot of times, so don't go too deep into that. Let's look here, HTML. and here are two files, index.html and CMD. The CMD is for the HTTP CMD configuration, an example. We're not talking about that. So yeah, we want to look into the index. Let's go back to ABMT. We have an IP address, but we also have an MDNS name, and we can access our ESP via this MDNS name. So let's go to the browser, new tab, ESP32.local, and we have our page here. So now the LED is on, and when I switch it off, yeah, so then it's off. Now it's at 56%. It's not that bright as possible, so now let's make it brighter. Here, yeah, it looks the same. Let's make it very dark. The linearization is not working properly, so yeah, it just looks as bright as before. Yeah, now it's turned off. So yeah, the linearization here doesn't work properly for this LED here. So yeah, it's just two values, on and off. Yeah, so yeah, that's an HTTP REST example that the ABMT nodes come with. You can use display application here. I have an e-ink display connected here. That's another example. Yeah, and you can select the chip you're using. I show you that here. So default chip is the C3. This S3 I added. This is not in the repo. I added this in a previous take and talk about this later. So this is not there normally. I remove it. No, I don't remove it. I show you this later. So we're coming with SDK configs for C3, C6, and a normal ESP32 here. And there's also a test configuration. The test configuration is when you want to experiment with an SDK config. You can use this. So let's go back to the GitHub page and we talk a bit about other stuff here. So as we started with SDK config, we are talking about this now a bit more. So basically what you do here, you select the SDK config you want to use. So it comes with this three because these are the one I use the most and are a bit stable. And so let's minimize this here and go to the runtime directory. In the runtime directory, there's a config dev, like in all runtimes. The config dev shows it's basically the template for this runtime configuration stuff here. And here we see the select box SDK config, and here's the select options. So in a previous take, I added the select option here to show this to you, and we do now now remove this back to original. So config, and let's remove this key value pair, remove, restart ABMT, ESP nodes. So now you see the S3 is missing. So this is how you add another config configuration. It's just this key and value pair. And the configurations are stored in SDK configs here. So when you want to add another one, you have to edit the config dev, and yeah, key value pair is, this is the key and the value is what's written here. So that's the config that's used. For most of the times, I think you will work with test and then make your progress, and when you say it's finished, then add another config here. So this is what the test is for, that you can experiment without changing the config and the config definition. Okay, so that's how configurations are added. And now let's talk about how you manipulate them. That's a bit more important. So we have the configuration, the model, we have the configuration HTTP CMD. Let's go into our project directory, ESP nodes, and here we have a build directory for that. So this is our build directory, build config, and here we can, there's this EDF script in this directory, and that's how you can execute IDF commands, IDF, and we can call the menu config, and then everything is set up like in your project, and now you can change stuff, TCP, yeah, whatever you want to change. So quit, and then there's the config, and then you can config the config. You can copy the config to this SDK directory. So maybe in this case, when we change it, we use the new SDK config to the target configuration. So copy SDK config to RT ESP SDK config, and in this case, or for example, then use the test one because you want to test something. Then you copy that to test, and then you select test here, restart, and that's the process about SDK configs. And of course, how to add other boards. So yeah, maybe talking about boards, C6 is maybe my new favorite one. I'm not very deep into that, but the low power capabilities are very, very good. Go down to 35 microamps. The main new thing is that it supports target wake time, so it can wake up every seconds you talk about. Yeah, I talk about this in a few seconds, about Wi-Fi setup and low power stuff. These boards, I don't really like them. They have not good Wi-Fi connectivity, and so the Wi-Fi antenna is bad, or at least for the ones I have, and the SDK configs, and this pin setup is not good. So I'm lucky that how they called, it's not written. Yeah, React Studio came up with this, and yeah, maybe this is my new favorite one. This is the old one. Yeah. So yeah, let's talk about Wi-Fi and low power. So I go up here. Yeah, there's several things you can do to achieve low power. I had a lot of trouble with that. So the Espressif guys have a very buggy stuff around low power. So for example, with embed TLS, the C6 hangs. Yeah, because a lot of stuff that shouldn't be like that. Yeah, I had a lot of trouble. So when you want to do low power, the main thing is get everything to work without low power. So and then activate low power and leave it like this. So yeah, and you have to make your own, find your own ways. Yeah, here are some notes. Maybe they change over the time. Yeah, when you activate sleep and you're not connected, it goes to deep sleep. It won't go to deep sleep when you're connected, because yeah, and that's what I like on these C3s. They have native USB serial converters, and they are turned off when you go to low power. So the connectivity is a bit bad, and you have to get them into the bootloader to flash them again, and so on. So low power can be very troublesome. Yeah, I make maybe another video about that. Main steps are: select your Wi-Fi power mode, select your interval, and enable sleep on idle to get into low power mode, and then leave it like that. So and do that when it's when you developed everything. Yeah, make another configuration for low power, for example. Yeah, and here's some notes. Yeah, Wi-Fi sleep modes. Let's talk about that. Minimum works very good. Then this configuration is ignored. When you go to maximum, then it listens to this listen interval, and when you have a target wake time for the C6, maybe other ones will support that too, but C6 is the only one I know, then you can extend this intervals to very large intervals, and it still will be available. So this is for ultra low power stuff. Yeah, go to this configuration, but then just send data out and receive. Yeah, it will be troublesome. So yeah, you have to experiment there a lot. So let's go further through this stuff. Yeah, here the common pins. The LED is GPIO8. Yeah, it's nothing really special. SDK config. Yeah, you have to disable the console in your standard SDK config, disable the log color stuff. These are some optional options. Yeah, debugging works very well. Yeah, so that's it. I hope you enjoyed it, and thank you for watching. Bye bye.